Guys, for our next lesson, we're going to talk about writing equations now with variables on both sides of the equation. And I think you guys will really be successful with this because what this lesson does, it kind of breaks it down for you so that the setup is there, what I need to know, how do I go about this. So first we have to talk about what did these words mean as far as math-wise, okay? When I'm reading a word problem, what are some other words that I can use for addition? Well, sometimes we see, instead of addition, sometimes we can use something like more than. If you see that, 3 more than 2, okay? That's going to be addition. Sum. A sum of two things also means addition. If you see the total, that also means addition. And there are a lot of different words that we can use, and let me just put one more. You might see increased by, okay? If you see any of those in a word problem, we know it's going to be an addition sentence or an addition equation. For subtraction, a lot of times we see less than, we see decrease by, okay? The difference, those are, I would probably say, the 3 most popular. The difference of 3 and 2, okay? 3 decreased by 2. 2 less than 3. We'll take a look at multiplication. And for multiplication, sometimes we'll see times, okay? Times. Product, the product of 5 and 5, okay? That's going to mean multiplication. And we'll do one more. Twice the number, okay? Twice the number, that's also multiplication. I would probably say product would be your most popular, okay? For this one, for division, we have a couple different ones, and I would probably say that the most, quotient, that's probably the most commonly used. We have a couple others. Half, sometimes you'll see half, but I would say quotient is probably the most important one, most commonly used. For equals, there's a 2-letter word that hopefully we know that helps us out, and that is. So 3 plus 2 is 5. And also sometimes when we're comparing two things, we might see the word same. That also means add an equal sign. So we can kind of use these and kind of work our way through what the word problem is asking us so we can go ahead and write the equation. Remember, for these, it's going to be variables on both sides of the equation. So let's take a look at the first one. We have Hudson, we have Knox, they're in a race. Hudson is running at a speed of 8.8 feet per second. Knox got a 30-foot head start, running at a speed of 6.3 feet per second. How many seconds will it take Hudson and Knox? Hudson and Knox are at the same place. All right, so what do you know at first? So you kind of step back and say, all right, what do I know so far? Well, you know Hudson, and he's running at a a speed of 8.8 feet per second. And I'm just gonna represent the feet per second as x, okay? We also, there's another person, Knox, and Knox, they tell us that he's running at a speed of 6.3 feet per second, but he's also given a head start. So we have to add in the head start that he's given. We have no equal signs right now. We have two different people running, and now we have an expression for each one, okay? So what do we need to know? We need to know when they're gonna be the same distance, When is x gonna equal the same, okay? So if you have a race, okay, and we're going here, we have Hudson and we have Knox, but Knox is ahead. But if you look at the speed, Hudson's faster. So eventually what's going to happen is Hudson is going to be equal with Knox, and then Hudson is going to be ahead of Knox. We want to see when they're going to be tied. When are they going to be at the same exact place? Well, now we can write an equation. And a good part to write an equation, a good kind of skill to use is, we know we have Hudson, we have Knox. So for Hudson, we know it's 8.8 feet per second. And for Knox, we know it's 6.3 feet per second plus the 30-foot head start. And then the same, when are they going to be at the same spot? There's our equal sign. And to go ahead and to solve this, we would just subtract our 6.3 from both sides. Subtract our 6.3 x from both sides, and we're going to get 2.5x equals our 30. And now what's happening to x is being multiplied by 2.5. So when you divide 30 by 2.5, we're going to get 12 seconds. So at 12 seconds, they're both going to be right here, Hudson and Knox. And after that, what's going to happen? Hudson is going to run faster. He runs at a faster speed. So at that point, he will then pass Knox. Okay, so on the back, let's see if we can go ahead and set up these equations. So we have celebrity A, and we have celebrity B. So celebrity A, celebrity B. Okay? Celebrity A has 400 followers on social media and is gaining 75 followers each and every day. Celebrity B has 1,000 followers but is losing 25 followers a day. So let's try and write an expression for A first. So 400 followers and is gaining, so you're going to add 75 followers each day. So 75 followers per day plus the 400 that celebrity A already has. Celebrity B is losing 25 followers a day, so that's going to be your minus 25 followers per day, but has or started out with 1,000. How many days will it take them to have the same number of followers? So again, we have that same number. When are they going to equal each other? And for this one, I would add the 25x to both sides and subtract the 400. Okay? So if I added 25x to both sides, subtract the 400, and solve for x, how many days? That's going to be, and you want to get used to putting that label in there. Okay? It's not just 6, it's 6 days. For the next one, Ben and his friends are going to play putt-putt. At one location, they get paid $2 for rentals plus $7.50 per game. Another location, it will cost $8 for rentals and $6 per game. So the key is, what is the variable and how do I indicate where that variable is? Well, there's a key word here that's been pretty consistent so far, okay? $6 per game, $7.50 per game. Once we see that per, that's gonna indicate, okay, how many games? So games is gonna be our kind of like our variable that we're gonna indicate as X. So X is gonna be the number of, so how many games at either location for the cost to be the same amount. So let's see. So we got location, the first location, $2 plus, so $2 plus $7.50 per game. Okay? In the other location, we have $8 plus $6 a game. So $8 plus $6 per game. We want to see when they're going to have the same amount. There's our equal sign. Now for this, I would subtract the 6x because I have less x's on the right side. And I don't want to deal with negative x's. So I would subtract my 6x from both sides. So minus 6x, minus 6x. Okay, so then on this side of the equation, I have 2 plus 1.5x equals, and I still have my 8 because those canceled out. I would subtract my 2 from both sides. So I have 1.5x equals 6. And the last and final step, as we know, divide both sides by 1.5. And then x is going to equal 4 games. Okay? So at the first place, it costs more per game, but they paid a cheaper amount for rentals. At the other location, it's more for rental, but cheaper per game. And when are they going to be the same? 4 games. Okay? Look at the last few here. So we have Haley has $155 in her savings account, and her brother has $230. So those are our 2 people, so 2 sides of the equation. So we have H for Haley, and then we have Hank. Okay? And I'll write this out because they have the same. So for Haley, she already has $155. So 155. Okay? Our brother Hank has more money, 230. Haley is saving $10 each week. So each week. Okay? So there's my variable. And the reoccurring situation, the reoccurring thing that keeps on happening, that's what's going to give you your variable. So each week she's saving $10. Okay, so $10. Oops. Try and stay consistent with my colors here. So she's saving. There we go. She's saving $10 every single week. So X, the number of weeks. Okay? Hank, okay, has more money, so he's saying, okay, well, I can spend more. I can spend some of this money I have in my account. So he's spending $15 each and every week. And then we want to see when they're going to have the same amount. So again, put our equal sign. In this case, I would add my 15x because I want to have a positive amount of x's. So add your 15x to both sides, here and here. And then subtract your 155 from both sides. And once you go ahead and do that, you're going to get for a final answer, it's going to be after 3 weeks. So after 3 weeks, they're going to have the same amount. Because he had more, she had less. He spends, so his bank account is going to decrease, her bank account is going to increase. And at 3 weeks, they'll have the same amount. Isabel takes a bus to work for number 5. The bus ride costs $2.50 each time. She could buy a bus pass for a one-time fee of $15 and would only pay $1 each time to ride the bus. How many times would she have to take the bus in order for the cost to be the same? Well, we know right off the bat there's going to be 2 parts of this equation. Okay? So she could take the bus ride to work and pay $2.50 each time. That's one part of it. The other option would be to buy the bus pass for $1. Buys the bus pass, okay? And then she pays that one-time fee of $15. So she pays that one-time fee of $15. Those are 2 different options there. I would probably say let's subtract our x from one side. So this would be 1.5x equals 15. And then we'd divide both sides and figure out, okay, what does x equal? It would take 10 times to take the bus in order for the cost to be the same. And then our last 2. 2 more than, so this kind of spells it out for you right off the bat. 2 more than, we know more than means addition. 16, so 2 more than 16 times, which is multiplication. So 16 times a number, and that number we don't know. That number is just going to be represented by x. We don't know. Is the same, we know same, which is going to be equals to 21 less than the product of -7 and a number. Okay. Whenever we see less than, this is 2 less than 3. So it's actually you actually have to like flip it, okay? So less than 21, got to kind of like reread it backwards, okay? Is the same as 21 less than the product of -7 and a number, okay? This is 21 less than -7 times a number. Best bet for this one, you can add your 7x to both sides, okay? Add my 7x, and get my 23x, okay? I still have my +2 on this side. That's gone on the right side of the equation, and I'm left with my -21. Don't forget your negative sign there. What I can do next, since now I have my variables on the left side and variables only, the objective is just to get the variables on one side of the equation, numbers on the other. I'm good here, but I'm not good here because now I have numbers and variables. So I gotta take this 2 and subtract it from both sides. So on the left side of the equation, this is gone. I only have variables, and what do I have for variables? I have 23 x's, okay? 23 times x. And I have a -21 minus a 2, which is a -23. And for my final step, I'll divide both sides by 23. -23 divided by +23 would be -1. Okay? And the last one, number 7. Decreasing -5 times a number by 18. Decreasing that number. So here's our number, -5 times a number. We're going to decrease that by 18. Is equal to decreasing 9 times a number by 25. Decreasing 9 times the number by 25. Okay, so there's your equation. You have two sides of it. Now we're going to solve for x. And in this case, I would say I'm going to add 5x because I want my x's to be positive. So they cancel out on the left side of the equation. I'm going to add my 5x here. Okay, so if I'm thinking about two sides of the equation, I have a negative 18. And then I have 9 x's plus 5 x's would be 14 x's. And then minus 25. Remember the objective, get x's on one side, numbers on the other. I have the x's only on this side, but I have my negative 25, which I have to get out of there. So the opposite of negative 25 would be positive 25. Okay, I've got my x's, and I have to add 25 here. And I have 7. Now be careful because we have 14 times x, so now we have to do the opposite. We have to divide by 14. So 7 divided by 14, which would be a half. Okay, it's not 2, it's not 14 divided by 7, it's 7 divided by 14. Hopefully this video helps you out with writing equations with variables on both sides. If you want to go back, pause it at any time, go back, check it out. Hopefully this helps you guys out. Feel free to reach out with any questions.